Welcome to Everything About Public Schools. This video series examines relevant public education issues ranging from equity to curriculum to classroom management to leadership and all the way to academic turnaround. Today's video focus is a mathematics curricular topic entitled Fractions, Decimals, and Mixed Numbers, Oh My! This video is the fourth and last in this arithmetic content series, and for that reason, it's aptly subtitled The Big Finish. It stresses connecting all fractional elements so students understand their physical relationship between one another, so that these skill elements are not learned only in isolation. My name is Blaine Hellwood. Glad you're joining us. The grade level intent is for 4th through 8th grade students. However, the process described in this video may be helpful to high school teachers tutoring students with academic skill gaps. There is a free downloadable PDF with commentary that includes all the skill resources referenced in this video. It allows teachers 0 to no preparation time to engage in the video's activities. The PDF document is located at the website thenewthree-rseducationconsulting.com under the Video tab. Or simply Google my name, Blaine Hellwig, and follow the links to the website. Let's get started. Qualitative versus quantitative understanding, an introduction. This perspective is difficult for many educators, mainly because there are so many interlevel teachers walking into our classrooms each school year. Moreover, a mass of classroom teachers exit the profession, approximately 44% after only 5 years. Losing quality teachers for any reason is devastating because institutional knowledge in any profession takes time, usually a lot of time. Let's see if we can shed some light in this important curricular area. The general pedagogical question that we are trying to define is, how do we provide students a qualitative understanding of arithmetic concepts, not just a quantitative one? This video will attempt to answer that critical question specifically by focusing our pedagogy and content on fractions, decimals, and mixed numbers. But how did we get here to the qualitative finish line in this video? We did so by small steps, both qualitatively and quantitatively, along our journey. We did not rush. We slowly built our knowledge. The 4 previous videos laid out this learning process. In them, we held our students accountable and prepared them for the next logical step. In short, we got rich slowly. Qualitatively will be addressed first. In the previous 4 videos, we drew pictures of fractional elements each time we presented them until the meaning of each of these arithmetic elements was mentally mastered by our students. We used tens and hundred grids. We used fraction diagrams and isolated fraction groupings, as well as number lines. A quick review of our qualitative images. Tens and hundred grids, fractional diagrams, isolated fractional groupings, and of course, number lines. All were intended to provide our students visuals that represented the quantitative computations. Again, qualitative visual models provide physical meaning visually for students that support and reinforce their quantitative calculations. As seasoned educators know, quantitative learning is also a necessary and required step in this process. Let's review the elements that were employed in the last 4 videos. Number 1. Math facts. Students knew all 4 fact operations to mastery, automaticity, for addition, subtraction, multiplication, and division. Number 2. Vocabulary. Students knew the definition with pragmatic examples of the following: numerator, denominator, proper and improper fractions, mixed numbers, and decimal numbers. Number 3. Conversions, equivalencies. Students could adeptly and consistently convert decimals to equivalent proper fractions and mixed numbers, and they could convert proper and improper fractions to equivalent mixed numbers and decimals. 4. Conversions again. Students also need to be able to convert mixed numbers to equivalent improper fractions. Number 4. Conversion equivalencies of mixed numbers to equivalent improper fractions was not shown in one of the 4 previous videos. So to be complete and emphasize our quantitative and qualitative process, let's provide a quick example of that conversion too. Let's convert a mixed number, 1 2/5, to an equivalent improper fraction. The quantitative calculations are relatively easy. Given the mixed number, 1 2/5, let's transform it to an equivalent improper fraction. I always use the clock's hands approach. Start at the denominator and multiply the denominator by the whole number, 1 times 5, and add the numerator 2 to obtain an equivalent and proper fraction of 7/5. The qualitative understanding of the process is also straightforward. 1 2/5 in picture form has one fraction diagram completely shaded 5/5 and the other 2/5. This matches the math. One group of 5/5 plus 2 1/5. Add the 5/5 plus the 2/5 to obtain 7/5. We write our equivalency. 1 2/5 is equal to 7/5. Part 1. Proper and improper fractions with equivalent decimals. We will not be using the mixed numbers at this point. Our number lines will begin at 0. With the mixed number to improper fraction conversion process complete, let's type fractions, mixed numbers, and decimals together. The video exercises that follow are what all state standards, Common Core, TEAS, etc. ultimately desire children to grasp with decimals, fractions, and mixed numbers. For example, students can equate the following. 1.5 is equal to 3/2 and is also equivalent to 1 1/2. And students understand that all three fractional elements occupy the same point on a number line. Then, mathematically, students can choose which fraction, decimal, or mixed number element is easiest to employ in a problem-solving situation, depending on the circumstances. Furthermore, if a career in STEM fields is a goal for your students, they must possess a high level of arithmetic understanding in this particular area. General instructional process and video overview. In Part 1, we begin with proper fraction decimal number lines. Then, after student mastery, in Part 2, we bring in mixed numbers to our number line. In Part 3, we transition to all fractional elements that are greater than or equal to 1 whole at any given point along a number line. The gradual release instructional method, I do, we do, you do, is used in all three parts. Let's begin with the 5th number line, proper, improper fractions, and decimals. These pre-made number lines are available to educators in the free PDF download. Our number line. Let's add whole numbers beginning at 0. 0, 1, 2. Count the equal spaces between any two whole numbers. It's important to note, many students have trouble correctly completing this step at first. They count the lines between the whole numbers, not the spaces. It's recommended to tell them, count the spaces and label the lines. Let's count the spaces. 1, 2, 3, 4, 5. Between 0 and 1, there are 5 equal spaces. Again, 1, 2, 3, 4, 5. Between 1 and 2, there are 5 equal spaces. Between any two whole numbers on our number line is divided into 5 equal parts. Therefore, our number line is in fifths. Let's add the proper and improper fractions to the number line. Now that we know the number line is divided equally into fifths, we also know the first proper fraction is 0/5. Let's add the improper and proper fractions. Quantitative work needs to be completed at this point. An equivalent decimal needs to be computed. Generally, I choose the first proper fraction, 1/5 in this case, because that's also the first equivalent decimal on the number line. Then, it's easy to count multiples of that decimal and complete the number line. Rewrite the decimal 1/5. Roll to the right and calculate an equivalent decimal. Write the equivalency. Add the decimals to the number line beginning at 0. Circle a proper fraction equivalency on the number line to ensure our number line is correct. Then, draw a picture to qualitatively verify the equivalency. So we need to check if 4/5 is equal to 0.8, since they both occupy the same point on our number line. Let's rewrite our proper fraction, 4/5, roll it to the right, complete the divisional process, and compute an equivalent decimal. Write the equivalency. 4/5 is equal to 0.8. Check. Finally, let's draw a fractional picture and make sure that our fraction is indeed 4/5. Check. Let's check another equivalency on the number line, but this time let's choose an improper fraction. Let's select 7/5 and 1.4. So we need to check if 7/5 is equivalent to 1.4, since they both occupy the same point on our number line. Let's rewrite our improper fraction, 7/5. Roll it to the right, complete the divisional process, and compute an equivalent decimal. Let's write the equivalency. 7/5 is indeed equal to 1.4 by our division. Check. Let's also draw a fractional picture and make sure that our fraction, 7/5, is equivalent. We have 5/5 and 2/5, which equals 7/5. Check. The instructional workflow with students, as described in Part 1, is estimated at 7 to 9 days. The direct teach I do of the number line process requires 2 days of mini lessons, but the teacher is talking through the workflow demonstration, communicating the process with students. The teacher can distribute the number lines. Students will only work 1 or 2 number lines per page per day. Students may place the number line practice page in their math folder for easy retrieval on subsequent days. Guided Practice 1, we do. Each morning before the core lesson, the teacher can conduct a quick mini lesson. It's highly recommended that the teacher work lockstep, concurrently with kiddos to control the learning process, keeping all kiddos focused. Guided Practice 2, we do. Continue the process. Every morning, work 1 to 2 number lines for 4 to 5 days until all students demonstrate mastery. As we did in Part 1, use only fractions, proper and improper, and decimals, beginning with 0 as the first whole number. Semi-independent practice, you do. Students work as per the teacher's instructions, while the teacher actively monitors. Repeat each morning until mastery is achieved. Independent practice, you do. Students work independently on a number line, or 2, to demonstrate mastery. Teacher provides clarity in the task with the number line, the equivalencies, etc. Then, the teacher checks their students' work and provides interventions as needed. Part 2, proper and improper fractions with equivalent decimals, adding in the mixed numbers. We'll begin again with number lines starting at 0. Let's add the mixed numbers to our number line. We are working one step at a time, so students are not overwhelmed. As before, all number lines are readily available for educators in the free PDF download. Our number line. Let's add in whole numbers, beginning at 0. 0, 1, 2, 3, 4, 5, 6. Count the equal spaces between any 2 whole numbers. Remember, count the spaces and label the lines. Between 0 and 1, we have 2 equal spaces. Between 1 and 2, we also have 2 equal spaces. And between 2 and 3, we have 2 equal spaces. Between any 2 whole numbers on our number line is divided into 2 equal parts. Our number line is divided into halves. Let's add in the proper and improper fractions on the number line. Add in the equivalent decimals. First, calculate an equivalent decimal from the number line. I invariably choose the first proper fraction on the number line, 1/2 in this case. I roll 1/2 to the right and create a division problem. This yields an equivalent decimal to 1/2. Write the equivalency. Add the equivalent decimals via multiples of 0.5 to our number line. Add in the mixed numbers. Let's compute an equivalent mixed number from the number line. I usually choose the second improper fraction on the number line, 3/2 in this case. I roll 3/2 to the right and create a division problem. This process yields an equivalent mixed number to the improper fraction 3/2. Write the equivalency. 3/2 is equal to 1 1/2. Add in the mixed numbers via multiples of 1/2. Please note that the mixed numbers start at 1. We could have used a decimal to compute an equivalent mixed number as well, but reducing fractions to lowest terms may be required. Last step, ensuring correctness. Let's check an equivalency on the number line and then draw a picture. We are trying to show that 7/2 is equal to 3 1/2 is equal to 3.5, since all three fractional elements occupy the same point on the number line. Let's rewrite our improper fraction, 7/2, roll the improper fraction to the right and divide, creating an equivalent mixed number, 3 1/2 to the improper fraction, 7/2. We proved earlier that 1/2 is equivalent to 0.5, so 3 1/2 is equal to 3.5. Let's write our equivalency. 7/2 is equal to 3 1/2 is equal to 3.5. Check. Finally, draw a fraction diagram. Yes, it equals 7/2, 3 1/2, and 3.5. Check. The instructional workflow with students for Part 2 is estimated to take 5 to 7 days. The direct teach, I do of the number line process also requires 2 days of mini lessons, and the teacher is talking through the workflow demonstrations, communicating the process. The teacher should distribute the number lines. Students will only work 1 to 2 number lines per page per day. Students may place a number line practice page in their math folder for easy retrieval. Guided practice, we do. Each morning before the core lesson, the teacher can conduct a quick mini lesson. It's highly recommended that the teacher work lockstep concurrently with kiddos to control the learning process, keeping all kiddos focused. Semi-independent practice, you do. Students work as per the teacher's instructions, while the teacher actively monitors. Repeat each morning until mastery is achieved. And lastly, independent practice, you do. Students work independently on a number line to demonstrate mastery. Teachers provide clarity in the task with the number line, the equivalencies, etc. Then, the teacher checks their students' work and provides interventions as needed. Part 3, improper fractions, mixed numbers, and equivalent decimals from any point on a number line. From any point on a number line, let's connect the mixed numbers, the improper fractions, and the decimals. Let's take this number line and add in whole numbers, but this time let's choose a starting point of 5. 5, 6, 7. Let's count the equal spaces between any two whole numbers. We will count the spaces and label the lines. 1, 2, 3, 4. There are 4 equal spaces between the 6 and the 7. Therefore, our number line is in fourths. Let's add the improper fractions to the number line. We know that 5 is equal to 5 0/4. Let's use this fact. Let's convert 5 0/4 to an equivalent improper fraction. 4 times 5 plus 0 is 20. 5 0/4 is equal to 24. Let's add the improper fractions to the number line. I know we are correct with our equivalent improper fractions, since 28/4 is equal to 7, or 28 divided by 4 is equal to 7. Add equivalent decimals to the number line. Let's convert 21/4 to an equivalent decimal. Let's rewrite our improper fraction 21/4. Roll it to the right, then divide. 21/4 is equivalent to 5.25. Let's add the equivalent decimals with multiples of 0.25 to the number line. Add equivalent mixed numbers to the mix. Let's convert 19/4 to an equivalent mixed number. Let's rewrite our improper fraction 19/4. Roll it to the right, then divide. 19/4 is equivalent to 4 3/4. Let's add the equivalent mixed numbers at multiples of 1/4. Let's check an equivalency on our number line, both qualitatively and quantitatively. We need to make sure that 6 2/4, 6.5, and 26/4 are equal, since all three fractional elements occupy the same point on our number line. Rewrite our improper fraction, 26/4. Roll it to the right and divide to calculate both an equivalent mixed number and decimal to the improper fraction, 26/4. Write the equivalency. From our computations, 26/4 is equal to 6 2/4, as well as 6.5. Check. Finally, draw a fractional diagram to represent our equality. Our fractional diagram matches our computational work. Check. The instructional workflow with students for Part 3 is estimated to take 5 to 7 days. The direct teach I do of the number line process requires only one mini lesson, 1 day. However, this is optional. Usually, at this stage, I jump right into the guided practice we do. As before, distribute the number lines. I usually keep 4 to 7 copies in the event a couple students lose or misplace their paper from the day before. Tip: students should leave their practice page face down until the teacher is ready to begin. Guided practice, we do, as in Part 1 and 2 of the video, continue every morning using 1 or 2 number lines for 4 to 5 days, or until all students demonstrate mastery. Independent practice, you do. Students work independently on a number line or 2 to prove mastery. Teacher provides clarity in the task with the number line, the equivalencies, etc. Then, the teacher checks students' work and provides interventions as needed. After completion of this unit, it is recommended to revisit the process every 2 to 3 weeks to ensure all students ingrain this content into long-term memory. This instructional thinking provides students threshold repetitions using only mini lessons for 5 to 7 minutes per day. A quick recap of the video, 6 major points. Point 1. The video connects fractions, proper and improper, decimals and mixed numbers, so students can view how the elements are interrelated to one another. Point 2. These fractional elements are usually only taught as isolated skills, unfortunately. Many children never grasp the big picture of these entities. Point 3. The pedagogical process shown in this video was stair-stepped to build a foundation using both qualitative and quantitative attributes that ensure students not only possess computational understanding, but they also visualize the physical meaning of the mathematics. Point 4. This high level of student understanding in decimals, mixed numbers, and fractions is the unstated goal of all state math standards in this country. Point 5. The math content level of this video is a STEM expectation for student understanding of fractions, mixed numbers, and decimals. Point 6. Students must know their math facts and background processing skills to automaticity to achieve mastery in this video's content. Thank you for watching. I hope this short video was helpful in your work in the public schools. Please check out our other videos and resources.